of cut off about a thing.
Uh, one of the things you could do if it's really bad is
Again.
just exit the meeting and restart and join it
Not
again.
again.
Alternatively, you could always
Join it again.
restart your computer. You could exit and rejoin, or you could restart your computer and rejoin. Let me know what
Okay.
you end up doing.
I'll try just. It's now. I'll leave just in case.
Yeah, sounds good.
One.
Hey Naomi, hopefully you're seeing my screen now. Yes, no, maybe. I'm not able to hear you if you're talking. I'm gonna drop a message in the chat, but it does look like you can hear me. You could check your audio settings. Yeah, I figured you can hear me. There's an up arrow next to where the mute button, or down arrow, actually drop down next to the mute button. And there it'll say audio settings, and you can check uh, your speaker and your mic, but your speaker is obviously working. The mic is not. Sometimes it just doesn't come on by default. Let me see if I can show you where that is. It's the drop down arrow next to the mute button on the little panel. You can also test it from the waiting room. That's another option. Um, Same idea though. It looks like that you're maybe unmuted. Maybe that helped. So there's a little drop down next to the mute button, and if you click on that, that's where the audio settings are to test your microphone. Okay, yeah, I see your message there. You see it. I apologize. I know this is pretty frustrating. It is important that we can communicate.
Hello?
Yes,
Can
I
you
can
hear
hear
me?
you
I can
now.
hear you now.
All right,
All
thank
right,
you
thank you for
you could
you could
lower the
lower
volume
the
just a
volume
tiny.
just a tiny.
Okay, that works for
That works
me.
for me.
Well, there's a
But
little
there's a little
feedback,
feedback,
Oh no.
which will be
which
a
will be a
problem.
problem.
Okay, maybe
Okay,
we can get
maybe we can
started.
get started.
No, there's
No,
still
there's
some
still some
feedback.
feedback.
Mm. I'm trying to fix it. How about now? Is it working?
Let's see. Is there any feedback? No, it's actually very good. All right, let's jump back into it here. You should be seeing my screen, and this is where you have to use the stuff from the previous problem to determine the alternative test. So there's a lot of information here. You're reading though, and you're looking for a word like increased. Increased means greater than. Decreased means less than. You're looking for keywords when you do this. You can read all this, blah, 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 but it really comes down to that keyword. So it's either this one down here or this one here. In your class, it looks like your null hypothesis is always going to have an equal sign. So the best choice there is letter C. Okay, and we'll get more into that. It'll make more sense tomorrow or next time you have class. All right, so let's keep going here. So is this what direction is the test? Because it's a greater than, and I'm going to snip this in here. So you can see that this is the next part of the question. Because it's a greater than in the alternative, greater than is right-tailed, left-tailed is less than, two-tailed is not equal to. So you can see that this is a right-tailed test. Okay, I'm going to skip the next one because I think you've got that down. Maybe we'll get to look for some numerical ones. Maybe we'll come back to that. Okay, so here is, and this is question 8. I'm skipping a few that, I mean, we can always come back to, but
Okay.
all right. So number 8 here, they're saying the graph to the right portrays the decision criterion for a hypothesis test. And they're telling you the null hypothesis mu equals mu0. So this appears to be the standard in your class. All right.
Yeah.
And the rejection region, what they're trying to show you in the graph over here is the rejection region is to the right of 1.751. So that's a Z. And I don't know if it's greater than or equal to. So it's either B or D. I'm going to go with D first. I know you get a few chances on this. It's not correct. So it must be B. Okay. All right. So they include that value as the rejection region. Small little nuance thing. So the non-reject region is everything to the left of it. So it's like do not reject, or if you're to the right, you do reject. And that's the other part of this question for now. We'll see what else it has. So clearly you can see it's like the other side of B. The other side of B is this less than. And so it's always split up that way. Like one side is a reject, one side is a do not reject. Okay. So now they want you to determine the critical value, which you already know because we defined it in the previous part of this. The critical value is that placed on the graph right here where it separates the two regions. So this dashed line represents the critical value 1.751. All right, the next thing is what's called the significance level. So the significance level is the area in the tail, or tails if it's two-tailed. But if you go back and look at the drawing here, the area is 0.04. This arrow should be pointing at the blue,
Okay.
but it's not really pointing at that point. It's 0.04 though. And the significance levels are pretty small. They're typically like 0.01, 0.05, maybe even 0.1. Okay. Well, this is weird. Why don't they just give you the graphs?
Uh,
So I'm gonna just skip past that one. I don't know what's going on with that. So we're gonna move on to question 9. Question 9 is really similar. Basically, it's the same question, different numbers. Okay, this one is slightly different. They're trying to walk you through this whole well, is it's one-tailed or if it's two-tailed, what is it? And do one more example of this type. So here we go. Let me snip this in. So this time it's a two-tailed test. There's a left tail and a right tail. I don't know if you have cats or like cats, but that's sort of the visualization is that long tail that cats have. If you're a
Oh,
dog person, dogs don't have as long a tail as cats. So the rejection region is the blue. The
okay.
blue area in the curve. So you can see it's left of 0.842 and then it's right. I'm sorry, it's left of negative 0.842 and right of 0.842. So it's this region here, left of it and then right of it.
Oh,
And then the do not reject region. The do not reject region is in between, or the non-rejection region. So you'll see that as well here. Let me grab a snip of that. There it is. Okay. So the non-reject region is everything in between that's in white. That's this here.
okay.
All right. And so
Yeah.
the critical values this time, there's two critical values. There's that positive and then that negative. So it's minus 0.842 and 0.842. Those are the two separators of that. And so later in this homework or in the next homework, you'll be calculating those values as well. All right. The significance level is the amount of area. So they're saying that this is 0.1 and 0.1. They're really pointing to the blue and the blue. So if you add those together, it's 0.2.
Okay.
All right. So we're going to move on here to some other questions. Okay. All right. So let's look at the next question here. There's a couple of parts from those last two that I didn't get to. Um, they're probably something you can do on your own. We'll see. Determine the critical values for one mean z-test. Draw a graph that illustrates your answer. So like until you've seen this, you're like, what is he even talking about? This is the normal curve. Okay. And what they're saying is this 0.11 is the total in both tails. Okay. But because it's a two-tailed test, that means you have to cut it in half, which is 0.055. So in the tail on the left and the right, there's an area of 0.055, 0.055. Now in software, you can go and look up the z values such that there's 0.055 in the tail, or you can use this table. What do you think you'll end up doing in class? Or does it even matter? I mean, you know, I can just do it in software, or do you want me to show you how to look it up in the table?
I think the table.
Okay, so let me show you that here. You're gonna find it. 0.5. Okay. This is kind of frustrating. It's kind of hard to see. Um, okay, let me grab a couple snips here. Okay, so here's the table. And then I sort of have to like massage this by feeding you the place in the table to look. It's kind of hard to know this ahead of time. Paste. Okay, let me see if I can line this up. Okay. All right, so not lined up great, but do you see that this, I'm going to highlight it here. This is 0.0548 and this is 0.0559.
Yeah.
So we want 0.055. So it's really, really close to that to that minus 1.6. That's the Z value. And then this up here you use as the second, the hundredths place. So in this row for minus 1.6, it's minus 1.69, minus 1.68, and so on. So it looks like that's the closest one, which is minus 1.60, positive 1.60. So the way this table works is the areas are in the middle. These are the areas, and the Z values are along the side there. And
Okay.
if that didn't make sense, you'll probably do some of those in class here to help. Sometimes when we just jump into the homework, it's kind of confusing rather than getting a little bit of instruction ahead of time. So you can see here the correct graph. I mean, this one on the left is what we just made up here. They're just specifying, hey, this is the do not reject region, this is the reject region, this is the reject region. This is the only of the three that's a two-tail test. This is a right tail, this is a left tail. So pretty straightforward.
Yeah.
All right. That one's numerical. Or that one's not numerical. You'll be able to figure that out. Where are the questions? Okay. 0.00. That one you could probably do. All right, here we go. So I'm up to 16. This is kind of where the like real numerical stuff starts. Everything before that is kind of, you could do one problem all the way through and then use it as a template if you needed to the second time around. All right, so it says a sample mean, sample size, and population standard deviation are given below. Use the one mean z-test to perform the required hypothesis test at the 10% level of significance. So you've been doing this for a while now. Z is x bar minus mu over sigma divided by the square root of n. Does that look super familiar to you? Okay. So let's put those numbers in. 28 minus 32 over 9 divided by the square root of 39. So I'd like you to carefully try to calculate that for us, please.
Okay. Okay. 28 minus 32.
How are you doing on this calculation?
I'm working on it.
Okay. Are you using a TI 8384?
Mm, I was on Tuesday, but I can't seem to find mine. I was using my brother's.
Okay.
I'm
Uh,
just using.
I- I'm asking because you want to use whatever you're gonna use in the classroom. Now, I put in the chat a calculator that I really like because you enter it basically the way that you write it. You don't have to like worry about parentheses and things like that. But you cannot use that on your test probably, but it's also an app. I'm not affiliated with them, but I'll just show you here that you enter it just like it's written. It really helps.
Oh yeah,
So I would recommend using that if you don't have access to a calculator today. And I know like most school libraries will loan one out to you. All the community colleges I've ever been to also give you one if you need.
okay. I'm just using something on. Are you familiar with Desmos? Does that work or no?
Yeah, that's the link I sent you is the Desmos
Oh,
scientific calculator. I would strongly recommend using that. And I snipped in a snippet of how it looks so you can do the calculation if you want.
it's showing a negative number. Is that right?
Yep, that could be correct.
And
What did you come up with?
you rounded it up to two
Two
decimal.
decimal places, yeah.
So negative 6.94.
That is not correct. Do you have it entered like this in the Desmos Scientific?
Yeah, I do. Or did I maybe miss a number? Let me check. Oh shit. My bad. I accidentally did 38 and not 32. There we go. I got uh negative two. I want to check if everything's right. Yeah,
That's sounds right. Keep going.
negative 2.76.
Yeah,
Shit, I'm
well,
sorry. Uh, I rounded down for some reason. Negative 2.78.
yes, there you go. Okay. All right. So let me enter that here and we'll do that. Let's see here. So the next thing, this is the harder part, I think, because of I kind of do want to know if you're going to be able to use your calculator or the table, but this is now wanting the critical values. So we have to go back to this. This is a left-tailed test, and it's a 10% significance level. So because it's a left-tailed test, that means the area in the left tail is 0.1. Okay. So we
Okay.
need to find this Z value. And that's where the table is going to really, really help here. If that's the way you want to go. So they don't give you the table this time. So let me see if I can have you check your class notes at some point and let me know if you have a Z table that's a PDF or something that I can refer to. I always prefer to use the student one. But the value here is, so I want us to keep using up your time here, that the value is minus 1.28. That's this C value.
Okay.
But it would be nice to have access to that so that I can use that during our lessons, that you're seeing what you'll see on the test. All
Okay.
right. And so now this is the last part, and this is the most important part of the class, like for me, if I were teaching it, because it's like it's not the calculations, it's like, do you even understand what we're doing? And it's a pretty straightforward recipe. Okay.
Okay.
Your Z value is minus 2.78, which is roughly there, minus 2.78. It's in the rejection region. Okay.
Okay.
So this, to me, this is the most important thing. You reject the null hypothesis. Okay. You reject if you're in the rejection region. So that's whether to reject or fail to reject the data, and then um, this is kind of the recipe. Provide sufficient evidence to conclude that the mean is, and you're going back to your alternative hypothesis, which is that it's less than 32. So you've got to kind of go back and grab some of these values like that. All right.
Okay.
So that's your first hypothesis test problem.
Well,
Probably not as exciting as like driving for the first time, but um, you know. All right. Sample mean, sample size, population are provided below. Use the one mean z-test to perform the required hypothesis test at the 10% significance level. So this time it's a two-tailed test because of the not equal to.
okay.
All right. So I want you to try calculating z. Z is x bar minus mu over sigma divided by the square root of n.
Okay.
Go ahead and try calculating that. All the numbers are there. I'm not going to put them into the formula for you this time, but I'm pretty sure you can figure it out.
Yeah. Excuse me. Okay, so I don't know if this is correct or not, but I got 1.51.
That is correct.
Yay.
Good job. All right. So the next part of the question is going to be roughly the same as the previous one.
Okay.
0.51. And I believe it's the drawing here. No, it's the critical value. That was a previous problem. So I mentioned that this is a two-tailed test, and we know that because of the not equal to. That's how you know that it's a two-tailed test. So in a two-tailed test, there are two critical values. There's one on the left and the right. They're the same except they're different in sign. And the how you get the critical value is based on the significance level. That's 10%. So that means that there is 5%, 0.05 here and 0.05 here. And again, you can use software to find this or a table. This one ends up being there's two of them. So that's why they use the plus or minus 1.645. We kind of talked about this the other day that you'll eventually like be able to get a table of these values so that you'll just know them without having to look them up. And then you can forget them after the course is over.
Okay.
So this time, this is minus 1.645. This is positive 1.645. So the rejection region, just to use the convention they were using earlier, is in blue. Your value is kind of right here, 1.51. It is not in the rejection region. Okay, so
Yeah.
for part C here, there's some words again to fill in. So this time you fail to reject. I don't know if your book say do not reject. Yeah, your book says do not reject. It's typically fail to reject. Do not reject. Um, the data do not provide. And then this time we go look for what's in here, we go back to the null. It's always the alternative hypothesis not equal to 30 and the drop down there. All right. Any questions, thoughts on that?
Um, to reject. Oh, okay, I get.
You'll see that there's a recipe for this, but you'll hopefully get more information in that class. So there's a lot of words here. Uh, you're doing a confidence interval. So for a confidence interval, as you know, it's X
Yeah.
bar plus or minus the Z alpha over 2 times sigma divided by the square root of n. So you have to be able to grab those um, numbers. So that's kind of the key thing here. So could you look at this passage, and specifically it's the second part here, and you're looking for X bar n sigma and then alpha. Alpha is the significance letter. Could you just take a minute or two to see if you can come up with those values from that passage?
Okay. Alpha. Suppose in the okay. 1%.
Do you have values for X bar?
Yeah.
Okay, what is X bar? You don't have to do the calculation yet. I'm just asking you to extract those numbers.
62.1.
Yes. So that 62.8 is actually mu, which is meaningless to us.
Yeah.
How about n? What's the
100.
sample size? Yeah, 100 sigma.
3.7.
And the significance level?
One. Wait, no. That's
0.01. Yeah, it's
oh,
1%, but you do it that way. Okay. So we have all the numbers we need except the Z alpha. So you use this to get Z alpha, which is the Z of 0.005. That's the 0.01 divided by 2. And again, you can use software for that. I think maybe in another lesson we can spend more time on that, but this ends up being 2.58. So this is 62.1 plus or minus 2.58 times 3.7 divided by the square root of 100. Okay, so use that Desmos calculator. See if you can calculate either the lower or the upper bound, and you're rounding to two decimal places on that. All right, I'm just going to jump in here because we are out of time. It ends up being 61.15 to 63.05.
Okay.
And it may not seem like we got through a lot in the homework, but there's quite a few questions that you'll be able to quickly do. I mean, the
Yeah.
grade's only showing as like 1/3 of it being done, but 10 or 15 minutes on your own, you'll have it up to a 60 or 70. And then there's just a few more numerical questions to do.
Okay.
So, all right, let's go ahead and we're going to stop right there for today.